Hello everyone and welcome to the OCP 2020 talk for RunBMC. My name is Jared Bednick and I will be presenting RunBMC, a BMC standard interface. My colleague Eric Schob unfortunately could not make this recording. So let's get started on RunBMC. So the last time we presented RunBMC was in OCP in 2019, and 5 months later, we were able to finally ratify the specification on version 1.4.1. What happened after OCP in 2019 was that we had many customers come forward to request changes or slight modifications, and then we were able to work towards a final version. So what does the specification actually give to the designer who wants to design a RunBMC module or a RunBMC compliance system? As you can see in the block diagram here, the blue arrow represents the actual hardware interface between a SODIMM receptacle and a 260-pin gold finger connector. All the different I/O that's required to run a BMC subsystem is exported over the connector. The system on a module side includes the BMC, some local DRAM, and other various things that comprise the system. To give an overview of the different types of subsystems we export over the connector, for host management, there's a single LPC eSPI dual interface, PCI Express as an endpoint, a USB host, USB device, and one VGA. Out of band gives you NCSI as RMII or a dual RGMII 1 gig base T interface and up to 5 UART. For motherboard and chassis management, there's up to 16 I2C, up to 4 SPI, and 1 SGPIO. And the environmental gives 8 PWM for fan and pump, 16 tachometer, 16 ADC, and 1 PECI. There's also various GPIOs, indicators, resets, and watchdogs with JTAG from the SoC as a master. This is all compacted into a 260-pin physical edge connector that's based on the DDR4 SODIMM form factor. If you recall from our presentation last time, this includes all of the various functionality that we feel is necessary in a BMC. What's different from what we presented at OCP in 2019? Some of the requests we had from different customers included adding dedicated pass-through pins, changing the slave bus for the SoC and FRU on I2C from bus 9 and no longer being bus 13. We added compliance for RGMII as pass-through, which is a stuffing option, as well as isolation for firmware SPI, which was a security concern from one of our customers. Here's a view of something else we accomplished since last time. We now have production-ready modules that are compliant with the published specification. Shown here is the HS2500, which is an A-Speed AST2500 based design that we co-designed with Hive Solutions. And also there is a Nuvoton, which is a POLEG SoC based module, which is shown here on the next slide. This POLEG-based module was co-designed with Nuvoton, and they helped us with some of the details related to the specification. So huge shout out again to Nuvoton. What's amazing is, as you can see here, these are both loaded into the same bring-up vehicle, which we call HSBUV, that allows for interchangeability between the two modules to verify the subsystems that are flaked out here. This is another plug for the Nuvoton base module. Here is Vertiv Avocent Core Insight running on Olympus with RunBMC. That is an Olympus motherboard with a RunBMC connector on it. And the Vertiv Avocent Core Insight firmware stack running on the Nuvoton based POLEG RunBMC module here features KVM and serial HTML5 consoles. It presents an open source Redfish-based dashboard, has a flexible portable Redfish engine, gives you firmware configuration tools for quick porting, and it's built on an OpenBMC platform. I'm also happy to announce that Hive has published OpenBMC code that runs on RunBMC, as well as putting up the HS2500 reference design based on the ASPEED AST2500, which is available on the OCP marketplace today. This is a huge accomplishment, and we couldn't have done it without Hive. So who is actually using this specification to build hardware? I want to give a huge shout out to the Intel team that created a design based on their Cyclone V SoC. They have a demo video for the virtual summit. I highly suggest you go check them out. Very impressive work that they've been able to do, taking our specification and creating their own module. And another shout out to Vertiv with Nuvoton. As you could see before, they were able to create an entire server chassis that adheres to the RunBMC specification. We also worked with Penguin Computing to get them up and running on RunBMC. They selected it for a number of reasons. They wanted an open compute project to complement their open rack mechanical form factor of a project. They liked having a large number of I2C and SPI channels available. They really liked having open BMC software for auditability and no license fees. And they like having Linux user space for flexibility. I'd also like to give a shout out to the companies that are interested or engaged in evaluating RunBMC. First up is Stratus Technologies, which provides fault-tolerant computing solutions for the edge and data center. They're targeting RunBMC to handle the management controller functions within compute nodes as well as the rack management controller functions across nodes. They require hardware elements to be redundant and serviceable while systems are up and running, so they will be working to add redundancy, fault handling, and synchronization functions to the OpenBMC code running on RunBMC. They're interested in involving the PCIe link on RunBMC to allow its use as a host port within the next generation of controllers. They'll be able to reconfigure components to handle failure cases as well as initial provisioning of resources. This is a feature that we're considering adding to the RunBMC specification, so we'll be working closely with Stratus in the future. Customer that we recently engaged is UFi Space or UFi Space. They adopted our specification to make their white box platforms more open and accessible to their carrier and service provider customers. Benefits that they saw from the RunBMC standard included a variety in PCB sizes for adapting to diverse boxes and chassis, standard board-to-board pinout to fit different platforms, rich and flexible hardware interfaces for communicating with various hosts of peripherals, and then using OpenBMC software with no license fee to simplify system software design. Some of the other companies that are using RunBMC include Datacom, Mercury Systems, Packet, and the University of Nuremberg. So for future designs, we are going to be designing a module based on the AST2600. This will support new features that may require us to extend the specification possibly to a V1.5, but we want to insist that backwards compatibility is a must here. I3C, PCIe root complex, and native root of trust on the SoC support are very interesting for the future of RunBMC. We're collecting requirements now, so please see our call to action. Join us in defining the requirements for the AST2600 module. Our OCP emails are up here. Help us to provide feedback on a specification that will expand to include new features such as I3C. I'm also proud to say again that Hive has the HS2500 reference module on the OCP marketplace. And you can find additional information on our Slack channel shown here, as well as an upcoming project wiki that'll be under the hardware management wiki. Thank you for coming to our OCP 2020 virtual talk. And once again, this is RunBMC. Thank you.